Do you know that in SIMION you can simulate collisions like the ones in a collision cell full of helium? In the documentation you can find a hard sphere collision model that is quite complete. In that model there are several assumptions. First, particles have a fixed radius and do not deform. Then, ion collisions are elastic. It means that after the collision, the total kinetic energy between the two bodies remains the same. Moreover, energy transfer occurs only via the collisions. Then, the background gas mean velocity follows the Maxwell-Boltzmann distribution. The mean velocity is centered around 0, but in SIMION, you will see that you can give a value, making the background gas moving. Kinetic cooling and heating of ions due to the collision is also simulated. When you fly the ions, the trajectories are affected by collisions. There is a Workbench program that you can copy-paste from the documentation. The program defines adjustable variables such as the temperature, the pressure, or the mean free path. My background gas is full of helium at a fixed pressure. If, for example, helium temperature increases to 300 Kelvin, I decrease the number of collisions. On the contrary, if I decrease it to 100 Kelvin, I increase the number of collisions. Another important parameter that you can manipulate is the collision cross-section. The diameter of the cross-section area is roughly the sum of the diameters of the colliding ions and the buffer gas particles. The value here I'm using is for collisions between helium and some 200 mass unit ion. If I increase it by 1 order of magnitude, I have more collisions. If I decrease this value, the cross-section is becoming so small that I have almost no collisions. Now, if I replace the background helium by something having a higher mass, 500 for example, I have many collisions, but you should change also the sigma value because otherwise you don't have a really correct result. Finally, you can adjust the pressure and it will of course impact the collisions also. Here my pressure of helium is so high that I have so many collisions that my beam is not transmitted. The Workbench program is quite long but not so complicated. In addition, it's well commented. First, it defines all the adjustable variables you can play with. I will not enter the details, but at each time step, depending on the temperature and the pressure you give, the mean free path is calculated. The mean free path is the average distance a particle travels between collisions. It depends on the gas pressure, the temperature, and the collision cross-section. Then, the probability of collision in the current time step is calculated. If there is a collision, the ion is scattered in a random direction according to the hard sphere scattering law. Remember elastic collision and the other assumption, but here we are working in the 3 dimensions. The velocity vector of the ion is then changed, and the ion follows its path, potentially undergoing more collisions at the next time step. The mean free path is also an adjustable variable. It is rare that you can fix it because it depends on the temperature and pressure conditions. It is because when you set it to -1, the mean free path is automatically calculated from the pressure and temperature. However, if you fix it at a specific value such as 4, for example, it doesn't take into account the other parameters. At this value, I'm reducing a lot the number of collisions, whatever the pressure. If I am increasing the pressure, the result is keeping the same mean free path. However, if I come back to a value of -1, with high pressure, my collision number automatically increases. And here, each red dot marks a collision. Remember that the mean velocity of the gas is at 0. While particles move in all directions, for every particle moving in one direction, there is statistically another moving in the opposite direction. But you can change that. For example, if you inject helium with a flow in one direction, the mean velocity will be different from 0. It's nice because with a flow you can change the direction of the beam. That's really interesting. Just a little clarification, the beam simulation here has a mass of 200 mass unit and a kinetic energy of 24 electron volts. I can change these parameters, and for example, if I'm increasing the energy to 1 kilo electron volt, I'm changing the collision pattern. Okay, that's the time for me to conclude that video. Collision cells are really used in many instruments to cool down or even fragment molecules, so my goal here was really to show you what you can do with SIMION, but keep in mind that you can go way further using the user program. You can, for example, combine the collision cell with ion optics such as quadrupoles or lenses that can keep ions inside the collision cell. You can even induce fragmentation using SIMION, and maybe this will be the topic of a next video, so stay tuned.